Hello, I'm Will Garlington, presenting the MyPl Decompiler for CPSC326 for the spring 2025 semester. So a quick overview of my extension. I chose to do a decompiler for MyPl, and that's a program that takes low-level or machine code and returns an approximation of the original source code. My implementation of the MyPl decompiler takes VM frame templates from the code generation step and converts those instruction lists within the frames into MyPl source code. And then that source code is then printed into a file decompile.mypl using the existing pretty printer. So we can quickly do a demo of my extension. What I can do is compile my program and then run this program. It's important to note that my mode is now set to decompile and my input is set to variable manipulation.mypl, and this is just a test in my testing suite. So I can execute this program. We can see up here, this is the instruction set that has been input into the decompiler. And then down here, we can see that my file has been successfully decompiled and is now in decompile.mypl. So we can inspect that file and the original source code, and we can see that everything lines up pretty much as you would expect it to, except for a couple of differences I'd point out. One is that the return null generated by the decompiler is an artifact caused by functions that don't have their own return statement in the original source code. And another important thing to note is that this line spacing that is present in the original source code can't be preserved in the final decompiled output. But going back to my presentation, we can go over some additional tests that I wrote for this project. So my first three tests are tests covering sort of basic variable cases. My first test, you can see on the right, is just an empty main function, and that's decompiled just as you'd expect with only a return null in the output. My second case is just using var statements to create variables of the 4 different types, and you can again see that that is decompiled as expected. And then my third case is actually the demo I just showed you, but we can get a closer look this time. You can see that my output, again, does not preserve the spacing, but also these binary expressions in the decompiled version, because they're using the pretty printer from the original MyPl, are generated with parentheses. And then this also happens, of course, when you nest binary expressions within each other. So overall, these tests just generate a basic functionality to cover obviously a sort of minimal case, variable declaration, and variable manipulation with assigned statements and binary expressions. So 2 more tests I wrote to cover functions. You can see this first test just creates 4 new functions, each with unique return types. And you can see in the output that this is generated perfectly fine with the correct return types and the correct return values. And then in my second test, you can see I've created some more advanced functions that have variable and assigned statements within them, just to make it a bit more complex. This is also generated as expected, except for one important difference in the double value function. You can see that my input variable is not being properly decompiled, and also my return variable is not being properly decompiled. This is due to some issues with variable handling that I'll go over later in the presentation. Overall, my architecture is virtually the same as the original MyPl architecture. The input file is compiled as normal until the IR is generated by the code generation step. At that point, those frames are passed to my decompilation syntax tree parser, or DST parser, and then that DST parser is actually creating a new program node to be printed into decompiled.mypl. Under the hood, this is reading the instructions backwards, starting at the return statement line by line. And as these statements are created, they're being put into new statement nodes that are then inserted into the statements list of the function definition. And as I mentioned earlier, once all these statements and function definitions have been created, that is passed back as a program and put into decompile.mypl. So basically all of the challenges I faced during the implementation of this extension were related to variable tracking. This was something I knew it was going to be challenging before I started, and it definitely was challenging as I worked on the project. My first challenge was just linking the actual variable ID to a number for the frame memory. This was the first major modification I made to facilitate the decompilation, and I actually ended up using a comment as metadata passed through from the code generation step to preserve the original variable ID. This isn't required, and I could generate variable IDs, but I think it results in a nicer output, and so I decided that it was worth it to include that as metadata. The second challenge was actually handling the variable and assigned statements and backloading them. I think figuring out the variable table definitely helped me understand the second challenge more. And essentially the second challenge is, as I mentioned before, the statements are read back to front. And this means that variable and assigned statements can't be created correctly on the sort of original pass of the decompiler. And so I solved this problem by saving the positions in the instruction set of these variable and assigned statements, as well as their correct position in the statements list of the function definition, and essentially doing a reconstruction set where I would use that information to backfill null values in the statement lists, generating those statements top to bottom in the correct order so that their variables could actually be tracked correctly through execution. So as for completion of my initial plan, I initially planned to have a full implementation with support for everything, including expressions, loops, if statements, arrays, structs, functions, etc. This was very ambitious, and at the time, I sort of didn't appreciate how difficult a decompiler implementation would be. And so ultimately what I accomplished was the literal value expressions, the var values for non-struct variables, that is where the path size is equal to 1, and then binary expressions. And then for statements, as mentioned, I've completed variable statements, assigned statements, and return statements. For future steps, I think developing a more advanced data structure to combine the variable table and assign and variable statement tracking and having all of that be rolled into one data structure would help development just by sort of centralizing where all that information is kept. After that was completed, I think working on structures like loops and if statements would be the next best step, just because those are most essential for actually having working logic in a program. And then I think once all of that was completed, it would be good to tackle structs and arrays, just because in some ways they are less necessary and also rely more on other components of the decompiler. So what I learned throughout this project, I learned that program decompilation is way more complicated than I initially thought, and it is in a lot of ways just as complicated and multi-layered as the compilation process itself. There are many problems that are unique to decompilation which make it more challenging. The big one I faced was data loss from the instruction generation, which required me to use metadata passed through comments. And overall, I just learned that the decompilation process is not as simple as just reading the instructions and generating code in a sort of linear fashion. And really, in a fully featured decompilation system, you need very complex data structures and a complex architecture in order to accurately recreate the original source code. So overall, I had a lot of fun with this project. It taught me a lot about sort of the difference between compiled and decompiled code, and sort of the issues in generating it. And it also gave me a good appreciation for all the work I had done with my compiler. But overall, I had a lot of fun with this project, and I think it was just a good learning opportunity and a good challenge to try and solve. But thank you. That was my Decompiler extension, and I hope you enjoyed it.